Hey there, CTF players. The challenge is now done, and I just wanted to record this quick sort of developer's commentary, walking through the whole challenge, showing the whole solutions to every part of the challenge, to maybe give you a little bit of eye on how it actually worked and all the solutions in case you were wondering. So getting straight into it, you might know the domain lives at ctf.hackthenorth.com. But if you just go straight to that domain, you don't go anywhere. And that's because we want to force you to complete the entry challenge first to get in. So as you might have seen inside our YouTube videos, the way in is through some things hidden on our static site at hackthenorth.com. So as you scroll around, you might see some of these signs right here with some shapes and colors. Another one here. And then another one all the way at the bottom past the sponsors. And there's cute little text here, but there's a bunch of signs. And if we follow the patterns on these signs, so going from the top, purple, blue, red, red, blue, red, red, purple, blue, and we go up to these gems up here, and we type in the code, you can see they sort of hover, purple, blue, red, red, blue, red, red, purple, blue. Auto scroll down and we see some kind of hidden discover challenge with a message welcoming you to your adventure. Clicking accept the challenge, you'll go down through to ctf.hackthenorth.com, and then here's a bit of onboarding. So we intro the CTF to you. We talk about some rules on what you should do, especially thinking outside the box, and that we explain it's only browse desktops. And we do explain some rules what not to do, so on brute forcing, on hacking other participants, on collaborating and attacking websites or sharing solutions. And then from there, if you type in every single italic word in here into the confirmation box, you get to go through to the next part. If you're missing one, you don't get to go through. And then finally, we say ready to begin, some final onboarding information, and we can go to the challenges. So I'm signed in on a fresh brand new CTF account right now. CTF@hackthenorth.com, and let's go through solving each of the challenges. So the broken calculator is the first challenge. It's meant to sort of make you hooked on the CTF and have a good time. And it's a funny bit of a calculator. If you do 8 plus 8, for example, 8 plus 8 is not 100. Or 3 minus 3 should be 0, but it's 4. So there's something going on here. And the way this challenge actually works is that each number is mapped to another random number, and each operator is mapped to another random operator. So here you see like 3 minus 3, or 8 plus 8. The only thing that really gets us to 100 would be like 50 plus 50 or 10 times 10. So 8 is 10, and then 2 given 3 minus 3, it looks like addition, right? So let's try again. 5 minus 5. 14, so it looks like 7 plus 7. So to get to 20, we would want to do 10 times 2, which gives you 20. Moving on to the next part, 315, sort of a bigger number. Let's go through figuring out the operators though. 6 plus 6. Okay, so this is 9 times 9. 2 plus 2. 25, so it's 5 times 5. What's this multiplication operator? It's addition. And then 315, I forget how to get to 315. 315 is 9 times 5 times 7. So in fact here, it's just the product of all of them. So 9 times 5 times 7. Boom, 315. Might be easy to just guess on your own, but the last one is slightly trickier. So if we do 4 divided by 4, we get 0. 2 divided by 2, we get 0. 2 divided by 3, we get 0. It doesn't tell us much, other than maybe the division operator is minus. But if we look here next, if we try to do the other operator, 4 plus 4, it's 4, which is odd. 2 plus 2, well, that's a big number. And 3 plus 3 is 27. And if you haven't noticed, this is the power operator. So 3 to the power of 3 is 27. And I think this is 5 to the power of 5, and this is 2 to the power of 2, which is 4. So to get 123, we're going to take 125 minus 2, which is going to use subtraction. So 125 is 5 to the 3. So if we do 5 to the power of 3. I think so. Here 3 is itself. 5 to the power of 3 minus 2 is 123. Great job. All complete and back to home. Now you've earned 1 more star. So this challenge was inspired by like fun math puzzles where you sort of have to figure out how to calculate numbers given a smaller set of numbers that you have. And I really enjoyed those challenges, so super glad to see it as a CTF challenge. The next one to move on to is the hidden repo, which is a very cool exploratory type challenge. So this challenge lives inside like a GitHub-like thing, and here's a solution path. So there's a lot of reading required for this challenge. You just should read through the thing. There's hidden repos. There's a warning, former contributor that was lost or obfuscated in the repo. So we're trying to look for something. So as we go digging around, the first thing you can see is just there's a .env legacy. It says do not commit the secrets, but there's this long big string, which is a little bit odd. And if anyone's familiar with some encoding, this equals at the end is a dead giveaway that is probably base 64 encoded data. So if you go base 64 decode, and you put in the base 64, we can decode it, and then here we have some text. So logical build, version, and there's a port, some information, and the core thing we want here is this sort of hex looking text, which is actually referencing to a branch name. So if we go back to the repository, we can see at the top there's a bunch of branches, and if in the end we search for this string, there's a feature branch. So going into this feature branch, something seems off, try downloading some files and decrypting with care. So this is sensitive files, .env you can't click on. Most of these you can't click on, but let's try to figure out ways to download it. I think if you go view commits, we can find a fix security vulnerability. It looks a little sus. And there's a zip that we can download. So if we download the zip, it downloads to your computer, and then pulling it up, we have the zip file here, and unzipping it and opening up inside the vault, there's an encrypted bundles, which is password protected, so we can't get in. So let's figure out based on the notes what's up. And then it's some garbled text, but the text reads, if you can read this, you have a strange mind too, you're the one to save us. To unlock the darkest secret, here's one more test. I flow without feet, I'm dark without night, I'm cast by the sun, yet I block out the light. I mimic your moves, but I'm flat on the ground. In caves I grow long, but do not make a sound. What am I? When you get in, listen closely to the voices. It says more than you think. So this riddle is riddling a shadow. So if we go to encrypted bundles and then type in shadow as a password, we get it. In here, there's archive logs, and there is a lot of text files, all of which just say what they have inside of them. And then this is audio file. Which sounds sort of odd. So what we can do is it does sound a little bit like some garbled up audio. And a common garbling technique, which is not that advanced, is to just flip the audio. So pulling up an audio editing software like Audacity, if we can import it into Audacity, we have our waveform, clicking this effect, effects, special, reverse, flipping it, we can play the audio.
Pandas, chases, pizza.
So if you didn't hear that, it went through my desktop speaker, but it said pandas, chases, pizza.
Pandas, chases, pizza.
So that looks like a good hint to me. So going into the archive logs, we can look for pandas, chases, pizza. So lion, panda, chases, pizza. And the other giveaway you might have got is that one of the files is much bigger than all the others. They're all a couple bytes, and this one's a couple kilobytes. So opening it up, it says, you're here to save us, Arya, which looks like nothing. But in fact, if you scroll down, there's more content. It says, listen to me, don't trust anyone you work with except maybe Dr. Nakamura. Her robot remembers all secrets, and whoever built this altered its memories. The machine is still listening, but to revive its memory, use this code, bamboo. This is your last chance to save us, and here's a cute panda. And in fact, there was nothing hiding inside the panda. It was a very cute panda. So Dr. Nakamura, that's something we want to remember. So going back to this project, we can go to issues, And you can see some issues, lost a team member missing, and a project from Dr. Emily Nakamura. So going through to it, there's a bot that says analyzing. This text doesn't really matter. But if you add your comment in and submit, the bot hears you. So you get your first partial mark, you get the star. And then to get the next star, you remember the crystals, they sing, listen carefully to their song, for in their notes lies the key. So access crystal map. It brings us back to main, but now there is this sort of map, a bunch of crystals, and it plays some sort of piano, which is a bit interesting. But in fact, what you can do here is we want to try to know what note each piano thing is actually representing. So to figure that out, if you have perfect pitch or you have like a piano next to you, you can try to match them up. But the more common solution is to get out a tuner app. And then I will use the tuning system to detect what kind of sound it is. So give me 1 second. So playing it a couple times, it says that it's a B. So I'm just writing this down on a piece of paper next to me. This is a B. This is an A. This is a C. This is a D. And this is a G. So to recap the pattern, it is a B, A, C, D, and then a G. G. Cool, so we have that, and then combined with the flag, it gives B, 5, 3, A, C, 8, D, 1, G, which is awesome. So going back to here, so we have B5, 3, AC, 8, D, G, D1, G. So we're going to go back here. We're going to go back to the issues, go back to the bot, and we're in the wrong branch. So we got to go back to our special feature branch, issues. Oh yes, there's a different thread where the bot talks. Update the thread when you hear the crystal sing. So this is the correct spot to put it. Oh, that's the wrong one. We want to put B5, 3, AC, 8, D, 1, G. So this other thread about the missing person, beep boop, you're so close, uncover the deepest secrets, hidden map, scroll bottom and download. So we got the key in there, and now we have another little final map to download. It downloads us a new file, and opening it up, final maze, there's a readme. It says navigate the cave system to uncover the final secret. And then if we open up the text file in our text editor of choice, we get this sort of big thing. And in fact, what it is a maze. And as you travel through the maze, you can try to solve it by hand, you know, sort of tracing here. You pass dots and dashes. And the trick here is that you want to decode these dots and dashes into text and read the output. So it's not too bad to write up some code that just does this. Lots of fun algorithms. And then the hardest part is just the most decoding. So I have a most decoding script. And then if I just go to run my Python script, python maze solver.py, it runs our whole maze, it gives our Morse code, and the decoded text is congratulations, please enter the final correct sequence into the goose hub to uncover the series progress. Previous flag appended with this long string is the final key. And if you're interested, here's a visualization of solving the maze. I know there are a handful of CTF players who did solve the maze by hand, which is insanely impressive. Congratulations to them. But we have this new flag. So coming back here, if we do our old flag appended with this, and submit. There we go. We finished the challenge. It's a quick plot twist reveal that turns out you were the one who disappeared. Very cool. Great job to the person on our team who developed this challenge. I think people really enjoyed it. And it's very cool. I like the exploration. I love the maze solving. Feels really creative. Good job. So now we get the gold star and we can return home. And right now we're at 3 out of 10 stars earned. Moving on to the Talking Cartographer. Talking Cartographer, it's a fun challenge about a goose who loves maps and the wild. And there's an AI chatbot you can go back and forth with. So the first thing is, the mystical goose appears before you, eyes glowing with ancient wisdom. Honk honk, you seek the path through shadows deep, listen well. You must trace the path from where the gathering begins to where creation flows. So this is referring to Gathering Begins. Hack North's opening ceremonies happen at Lazaridis Hall. And where creation flows is E7. It's where Hack North, the actual event, happens. So along your journey near University of Albert, you'll glimpse a chariot of the city marked with numbers and a destination. So this is referring to a bus, and then what words does the vessel bear? So let's go figure this out. So it might be a little bit confusing. It's like, yo, where do I find this? Sort of confusing, but the bot can guide you a little bit. So seek the digital realm where the paths converge. So this is really hinting at you to use Google Maps. So let me pull that up. Okay, so pulling up Google Maps right here, we can see that the 2 points it's talking about is E7, so where creation flows is located right here. And then the path from E7 to Lazaridis Hall is here. So if you look at the satellite, so this is the ceremonies, and this is here. And then it wants you to talk about University of Albert, which is this intersection right here. If you drop down your little Google Maps street view, you have a map, and if you look around, depending on the exact location you are, there's different buses that show. Nothing yet. We do change different years data, which is sort of confusing sometimes. So you can ask the bot to clarify the year, but if we show more dates, June 2024 is what we want. So this, I think, just updated with new Google data. But if you talk to the bot a little bit more, it can tell you June 2024. And then here, there's this bus that says 19B Northfield Station. So if you go back to the bot and you say 19B Northfield, it'll give you the first sort of part done. The next part is slightly harder. So where the path begins, the Gluce's eye gleams. So well done, traveler. The digital realm has revealed its secret to you, but now you must bridge the worlds of virtual, physically unique. Hidden whispers. And the important part is inspect the realm beneath the surface where developers speak in silence. So this is referring to the developer tools. These whispers hold coordinates to sacred monument. Decode the ancient tongue and venture forth with your own feet. The true pilgrimage demands your physical presence. Upon the monument thick of paint lies the next key. So this challenge is sort of hard, but is solvable online, and I'll show you both the online and the in-person method of doing it. So if we open developer tools for this site, and then we go to the dev console, there's a message that says a feather lands, and there's a whisper, and there's some base 64 again. So it's base 64 again. So if we switch back to base 64, decode it, we get a set of coordinates, which is awesome. And then if we pull up our Google Maps again, and we type in these coordinates, we get a pin on the University of Waterloo campus. And going to Street View, we do see this statue. So this statue holds a secret. I think it's sort of what the bot is referring to right here, where it says, upon the monument thick of paint lies the next key. So let's go solve that in person right now. So arriving at the coordinates, we can go all the way to this statue. And it was recently painted for engineering day, which is very nice. Good luck on your exams. But if we go around the back and look carefully, down at the bottom, there's a little text written that says Northbound Echoes. And this is the secret for this part of the challenge. And it's on this statue right here. That was the way of finding the key in person, but I'll also show you the way of finding it online. So if you take these coordinates, you put them into Google Maps, and you just search, you don't get much. So you can talk to the bot a little bit, and sometimes it can give you a bit of a hint, but it can be a little bit hard to figure out. But the solution that eventually the bot reveals to you, and if you ask enough good questions, is to search it with exact matches. If you didn't know, when you search things in Google with quotes, it looks for exact matches. And when you search for that, you do end up finding a Reddit post about the statue, which mentions its coordinates. And in the Reddit post, if you go to it and you read, you'll notice that there is a lot of CTF interest. But as you scroll down, there's some comments. But if you go look at the statue, on the statue itself, in small, at the bottom, it says northbound echo, which is the same string that we saw at the same exact location in person. So if we go back here and type in northbound echo, there we go. We earned the third and final star for this challenge, or the first star for this challenge, sorry. The last hint is the goose with its wings, building power, and there's a text, and in the text is a bunch of numbers. Sacred communication sequence reveals itself. So 5, 4, 8, and as you might be able to hint, the secret communication sequence refers to a phone number, and 5, 4, 8, 9, 5, 4, 8 is a reasonable phone number, and then 9009205. If you take that whole phone number and type it into a telephone, which is what I'm going to do right now. So 5, 4, 8, 900 9205. Call it.
Cradled in earth where the fire once slept, I'm born of the heat where the ancients wept. Blood of the mountain, hardened and clear. A gem among stone where the brave often tread. What am I? Take your time. What do you think?
So I'm muted on the phone right now, but this is an AI chatbot you can talk to and ask about the riddle. So they just gave you a riddle talking about some rocks and gems. Is it obsidian, maybe?
A clever guess, for obsidian is indeed born of fire, but it lacks the hue of blood and the sparkle of a gem. Think deeper. What stone might carry the mountain's heart?
I don't know that many stones.
No worries, my friend. Here's a small nudge. This gem shares its name with a programming language. Does that spark an idea?
So if you're not aware, there's a programming language called Ruby, and it's also a gem. So, oh, is it a Ruby? And then if you say that, the bot does hang up the phone, which may be in case that you maybe got the right answer. So if you come in here and you type in Ruby, there you go. That's the right answer to that riddle, and you win. So now let's continue on your journey and let's get some more stars. So continuing down the path, the next thing we have is the Lost Archives. Lost Archives is a challenge about a library where there's a bunch of archives and documents in there, and there's a glowing terminal that you can type into. So the fetch manual of fetch manual 000, typing in this command, entering it, the system retrieves us a document, pages manual 000, which is a manual for a text like collection thing. There's a bunch of explanation, explaining the core command, which is fetch, and some translations, and that there's two languages here. There is like English readable, and there's also an archival glyph script that's used to store things long term. And there's this, the document reading is called manual 000, and there's this other string that's sort of deciphered but looks similar in this other language that we might want to fetch. So if we go back to the terminal and we look it up, fetch, we then receive a new page. And if you just type in like fetch blah blah blah, the system will tell you there is no page found. But coming back to this page, now we have another page, but this is absolutely sort of unreadable for us. But the core thing to notice is that these two pages are almost identical. They have a bunch of similarly formatted text, so it looks like they're translations of the same page, but since the bottom of this page was cut off, and there is some stuff here, maybe that's something we want to decode. So what we can do here is, this is like sort of a cipher, where we are encoding between two formats, and each letter in English has an associated letter in the translated format, and vice versa. So they're one-to-one translations. So what you can do is, by going through each letter here, either by hand or using some code, you can match up that T is still T, H is A, E is D. So you can see that the and the here match up. So the something, And then what I encourage most people to do is to write a script. So I made one here called translate, which pretty much just has the whole table and then let's just like translate it. So if I do Python translate.py, and then we want to decode, pass in this text, it says, the employee conversation board is maintained in English. To access it, fetch chafob 141. And you can see that there's also a dash here in the original text. So if we come here and we search chafob 141, we enter the document. So we enter this document. It is entirely ciphered. And what we can do is we again should decode this. So going back to the script, encode a text, we're going to decode it, and our script decodes a bunch of stuff. So if we go to the decoded text, and it says the employee's post is notes in the jar. I can't believe we're hiding fortune cookie notes in the cookie jar. Every time I grab a treat, I find a note instead. Feels like they want us to read our own secrets. Next thing you know, they'll stash riddles inside the sugar bowl. Just be careful not to eat the paper by accident. I already bent in the note this morning. So it's sort of talking about notes hidden in cookie jars, and in software development, cookies refers to some browser storage, which stores information for your web session. And if you check your cookie jar by going to your console application, there is an archivist memo page. So if you fetch this page, and it is possible to sometimes find this page without even fetching this document first, which some people did, which is impressive. Finding this page, you can then get it, and then you can go back to the challenge, and you can fetch it. So fetch in memo. And along with that, the machine spits out a star, so you get your first part mark. And now looking at this page, we have a discussion. Has anyone gotten the serve command to work? I've heard rumors, top secret 999, but I've never succeeded in my terminal. The parentheses are strange too. Hard to say. There's a little bit of gobbledygook here. If anyone gets a result, let us know, but maybe it's a myth. So if we just try to do, as this top secret document, if we try to just fetch it normally, it won't work. Document not found in archive. If we try to do serve, access denied, console authorization required, which is a bit interesting. We try to use like the parentheses, like it said, unknown command, no progress. But what we can do is it's referring to another console, and there's the command console terminal that we're using here to type in, but you can also, as the challenge is getting you to use the developer console. And if you type in serve, it says, it prints something in the console, serve missing argument, serve document, for example, serve top secret 999. And if we serve and use serve as a method, then it does return us a document, a secret document, top secret 99999. Very cool. And then from in here, we get a memo about some translation irregularities. And the flag is hidden, and there's 4 documents. And the idea is that the translators translated mostly things normally, but certain words are in English, but appear in archival script glyph or other way around and are otherwise mixed up and remain in cipher, and they're embedded into the English paragraphs without proper encoding. So going from here, we can go look at all the pages we've collected already. Here and look out for some anomalies, and anomalies we're collecting are this text here. This one has nothing sus in it. This one did have this string. And then back here, the only sus thing is overall 5 pages, which in the decoded script really doesn't mean much. So going over all these, if we decode these encoded words, this says numbers. So overall 5 pages, numbers. This right one says sum of, and this EGH la la la. Flag is. So what it's saying is the flag is the sum of numbers over all 5 pages. So what we should have to do now is you have to pull out a calculator, and over all the pages, we have to take the sum of all the numbers that we see anywhere, not just the digits of the actual numbers themselves, So going through the whole page, the numbers are, I'll do it with you. So get our calculator. We got 0 plus. Here there's an 8813, there's a 1, there's a 0. That's all on this page. Here there's also the same 8813, there's a 1, that's a 0, and there's also a 141 at the bottom. Next up, if we go to this document, there's a 141 at the top. There's a 5 in overall 5 pages. And that's it for this page. In memo, there's a 424, a 999, and that's it. And then in this last page, there's a lot of numbers. There's a 999, there is a 141, there's a 424, and there's also this version mentioned at the bottom. 813224. And adding it all together, there's also a 4 here in all 4 documents. Here we go, plus 4. 29,044. So if we go flag 29,044, there we go, we finished challenge, we earned a star, and we can return to the hub. So that's the library challenge. Hopefully you enjoyed the ciphering, the digging around, the putting the pages together. It's inspired by Tunic, the game. And last but not least, we have our hardest challenge. We have the 3 murals challenge. This challenge is very difficult, but it's very satisfying to when you can figure it out. So the core idea behind this challenge is that there's 3 murals here, and if we look at each of them, they sort of have some like cave drawings on them. So one of them shows hello, and then the H with some binary. This turns out to be the ASCII binary for the letter H. Then we have this sort of bull with some color values, and these color values vaguely line up with like the purple color here. So it's like some data, and there's 010 that's underlined here, and there's some data in the bull. And then there's these same sort of data columns being adjusted. So in the bull, there's 010 at the top, which lines up with this 010. Then these gauges line up with these gauges of data. And then we can see that we're trying to align the last bit. So there's a 0 here, and then there's another 0 here. So this one is aligned. This one, there's a 1 above and a 0 here, but it gets like adjusted upwards to get a 1. And similarly here, there's a 0 above, but there's a 1 in the last position, so it gets adjusted down to be a 0. And this whole process over these 3 murals is describing the process called least significant bit stenography, which is pretty much a process of hiding data inside pictures. And the way it works is that each bit on the RGB channels of a picture stores some data in them. And then in the last bit, and if you decode the last bit of every single one, you get the data back out. And it does store the data without like changing the original image a lot. So it's a very slick way of storing some data, and it's sort of a classic technique. So we download each of the images. We have them in our downloads folder, and going back to our code, there are online digital stenography tools that you can use that are very cool, that can decode some of these images, but we encourage you to build your own tools. So I built here a script to decode the stenography, or both to encode and to decode. But using this script, we can run it. So we can make sure the target image is 1 encoded. I'm just going to decode 1.png. If I run python stenography.py, decode. So decoding 1.png, this file we just downloaded, the data that's hidden inside of it is, oh my gosh, thank the gem, someone finally found me. My name is Flag Pebblekin. So Flag Pebblekin is the first sort of part marks flag that you submit here for decoding the first image and having figured out that stenography is the trick here. I've been staring at these murals for a super long time now, but totally stumped. All I found was a schematic, so hopefully it helps you out with the next mural. And then there's a link to a schematic. So opening up the schematic, there's a circuit diagram. So for anyone who might have done some electrical engineering courses or even done medicine in Minecraft, You might be able to recognize this as a circuit diagram, which has a bunch of logical gates on them. So it's like AND gates, there's NOT gates, there's OR gates, and then there's something that says RGB 0, 1, 2, 3, 4, 5, 6, 7, and there's most significant bit and least significant bit. That's what MSB and LSB stands for. And then there's a data out. So the idea of this circuit is that it's going to describe a method of encoding or a method of decoding the data hidden inside the second mural. So MSB is you're going to take like the most significant bit, put it in this slot, the least significant bit in this slot. You're going to fill out all the bits, and then if you run it through the logical gates, you'll get your data output bit. And then by reading that bit and building up all the bits together one after the other, you will decode a message. And this is a much more destructive way of doing stenography. In fact, if you really look closely at the images, 2.png, at the top of the image, you can see the data is encoded right here in this sort of line of text. So we built a different circuit. So this circuit does this data, and here's the bitwise logic that like takes the input bits and then runs this circuit on it. And then otherwise you just have to do a little bit of utility to convert text to bits and do all the work. But if we want to decode 2.png now, we can run python circuit.py. And decoding the message, it says, congratulations on mastering the flag Vexillion interlock circuit, which is a very cool circuit that we just made up. So if you go back to the challenge and you put that in as a flag, you get your next part mark, which is great. Now we're at 9 out of 10. To unveil the next truth, step back and look within at the friend who was there long ago when you answered the summons. If you face with transparency, consider disregarding alpha. Those unruly fourth components disrupt the expected ternary order. So what this text is hinting at is it is hinting at the friend who was there long ago when you accepted the summons. And if you remember the start of this video, we started on our static site trying to find the challenge. And if you go down here, the friend who was there when you accepted the summons is in fact, the summons were served right here. This is where the text was. And there's a little friend right here. Very cute looking goose. And in fact, if you go and download the goose is a PNG. And if you download the goose and you get him in, we have this goose cart, and this is where actually our last little chunk of info is stored. So if we go to stenography and then we want to decode, we can just call it goose. Python stenography.py goose decode. It says honk honk. I've heard flag echoes beyond the pixels should be submitted to ctf.hacksonearth.com/challenges/3murals/upload, but I don't know how to make it fit. Honk honk. So if we just try to submit this flag to the CTF, we can just type it in and paste, and it says this flag looks familiar, but this isn't the right spot to submit. So if we go to the link that it gave us, /upload, we see a flag submission, upload a PNG image to reveal its hidden secrets. So what it wants us to do is it wants us to upload an image. And if that's not clear enough yet either, inside the third image, if you decode it, 3.png, third image says, have you found what was hidden? Now send it back the way you got this message. The true flag is now yours to deliver. So the idea is that all these messages were delivered to you through stenography encoded images. So the way to return the answer is going to be to re-encode the information into like a stenography image yourself. So what we can do is if we go secret message and we want to paste in our text, flag beyond the pixels, and then we encode, and then we have this encoded image where we hit our secret, and then we go to the /upload. So if we go here and we go to the upload link, and then we choose our newly encoded image and paste it in, and click decode, we finally complete the challenge. You have successfully decoded the hidden flag, flag successfully verified, continue your journey. and it decoded the flag echoes beyond the pixels that we hid inside the picture ourselves. Turning to home, we now have earned all 10 out of 10 stars for the CTF, and that's sort of it. So I hope this sort of walkthrough and developer commentary was interesting. It was really fun to develop this challenge for you all, and it seems you all had a great time playing it. There was no hidden 11th star. This is all the stars you can earn. But yeah, hopefully you enjoyed the walkthrough, enjoyed playing the challenges, and we're super glad to have provided to you, and we hope that you have a lovely rest of your year, and we'll see you around.